Okay, hello, this video is going to be about epigenomics. It's an exciting field that's kind of fresh in the last like 40 or 50 years. Um, Unfortunately, the way science in the mainstream works, the breakthroughs and what becomes common knowledge in some niches of science are not known to the masses for sometimes between 25 and 50 years. It doesn't become common knowledge. Think of the world transition from everyone for how long thinking the world was flat to people accepting it as round, now to questioning if it's round again with the resurgence of the flat Earth movement and stuff like that. Anyways, so epigenetics really should be something that's being screamed from the scientific mountaintops. There's a concerted effort to downplay the sheer magnificence that is this field, and I can understand a lot of agendas for that. One is ego, one's profit, one is protecting the sanctity of institutions like mainstream medicine and things like that. But it doesn't really matter. The point is, there is an effort to suppress how magical epigenetics is and how monumental the implications are for what is the effect it's going to have when we hit the 100th monkey level, or when the public picks up. Because what's magical about epigenetics is it basically now allows us to uncontroversially and unequivocally determine whether something is positive or neutral or negative, biologically speaking, right there on the genome itself, in the form of these bits of chemistry that are laid over and taken up from the genome itself. So epigenetics is outside of genetics or above genetics. So you have your nucleus, your material that's reproduced when a cell splits, and in sexual reproduction, what zippers together with the I don't know, what are they, the ovum and the gamete, or whatever the names are, to become the embryo. And that's pretty much static, not precisely, but for our purposes, for general purposes, it's pretty much static. If you take identical twins, they should both have the same DNA, for example. They they are made when in the birth canal, or in the womb, basically precise duplicates, because they're running off of the same blueprints. But once they get out of the womb, if you took them to different sides of the planet, fed them different things, gave them different life experiences, one rural, one city, they would grow up being different heights, different appearances, different quality of skin tone, things that, if it was just the DNA as it is, if that's all that mattered for governing how we express our biology and our health, then that wouldn't occur. So what's happening is, everywhere we go, we're developing in lockstep with our environment. And so that's why if you take a wolf from the Arctic that's just got thick mats of fur, just, you can get nice big handfuls, and then you took them somewhere warm like the Sahara or the Caribbean, and you had them be out in the heat. If they survived, which some animals wouldn't, you probably couldn't do that. It would be too much of a shock with like a polar bear, but maybe you could get away with it with wolves or foxes or something like that. I know it works with African lions because we've seen them, what happens to them when we take them into cold climates, and they develop all that extra fur. That's the reverse of this. So if you took that wolf from the northern climate where it's got that bushy, and you took it to the equator, and it's scorching every day, 70, 80, 90 degrees, and sun and dry heat, if almost immediately that wolf's senses, due to probably magnetics, but also just the sheer temperature, is going to start shedding fur as quickly as possible until that animal gets to its least amount of fur for the climate it's in, which the wolf is going to be almost a naked version of itself in that kind of a climate, because the body will realize that every bit of extra fur is going to cause a tax in terms of taking up resources and causing overheating. The body is hyper intelligent in most cases, especially with larger, more complex organisms like mammals. But that's happening with us all the time. When you go on vacation and you eat new foods in a different place and you're having different geography and you're feeling, either more uptight or more relaxed depending on how you go on holiday. And when you go to college and eat cafe food, that's shaping your genome. And then when you get vaccines, everything you do in your life is basically getting recorded onto your genome in some fashion, whether it's positive, neutral, negative, by our estimation or by our judgment. It's occurring, and that's it. It doesn't just stop with you. We've learned that as much as like 3 generations back at least, and it probably goes a lot further than that. 3 generations back, we can see that if this great grandparent experiences this XYZ, whether it's smoking or alcohol or exposure to glyphosate, I don't remember what all the studies, how they were labeled, but the point is that you'll have markers on your genome that wouldn't have been there if your grandma or grandpa didn't smoke like a chimney, or if they hadn't been alcoholics. It's almost as if, it's not almost, it's precisely as if your DNA, as it gets passed on, is recording what you might have to deal with when you get here. So it's going to build you better, faster, stronger for that situation, unless the exposure, whatever you're being exposed to, is like a chemical and it mutates the DNA. Then you'll have kids coming out with Down syndrome and just being, I think most of my generation is just a little bit less stout and a little bit less thick overall, because of the industrial foods and all of the sheer amount of toxins that our generation, I mean, I didn't live on any natural foods or anything healthy for the first 16 to 18 years of my life. It was fast foods, microwave foods, candy, soda, vaccines, chemical cosmetics, chemical hygiene items, chemical cleaning materials. But just everything in my life was designed to damage my epigenetics and cleave off telomeres and cause premature aging. And you can get into depopulation and all that kind of stuff, but it doesn't really matter. The fact is that we now have the smoking gun evidence with epigenetics that it doesn't have to be this way anymore. And that's what the public needs to get hip to, because once they have the numbers, I mean, if you fully understood the implication of epigenetics, you would realize that the tools are all there in existence right now to sue the ever-living daylights out of Monsanto, Bayer, Dow, Cargill, all of these CAFO, livestock, crop, chemical companies, GMOs, all of these things. You have a magic bullet now, and that is the evidentiary body of epigenetics, which will tell you that yes, glyphosate is causing cancer in nearly 100% of lab rats if the studies go to 6 to 9 months or whatever it is. So that needs to be done for humans, because as the most recent stats I saw is we are peeing 1,200% more glyphosate today than when it was first introduced. So that's all I've got on epigenetics. The main thing is that we can now watch disease happen on the genome, and therefore we have the smoking gun for what is healthful versus what is considered to be a toxin. And that changes the game, because it indicts synthetics and stress and Western schedules And natural law is completely the opposite of all of that. Natural law is what protects your epigenetics.